Hi guys, today I'm going to teach you how to solve the square one. This particular square one is made by Cube Twist, and personally it's the smoothest thing I've even come close to with the square one. I've had a few over the time and they've all been pretty stiff. For any of you that don't know how it works, there are 4 corner pieces on top, 4 edges, same on bottom, and then one middle layer which only has 2 pieces, meaning to turn by a certain angle you'll need to turn the top or turn the middle to line up all the way down like so. Now there's 2 stages to solving the cube. The first one is to get it back into its original state, and secondly, because it is a shape shifting puzzle, and secondly you then need to orientate and permute all the top and bottom layers. This cube does have parity, and there are 2 types. One is that you can have an odd edge switch parity, where you'll need 2 to swap on the top but all the rest are done, so you can't just swap 2 edges. Secondly, you can have the middle parity, where these 2 are flipped round, but that's easy enough to fix. The first one, I do not have a solid algorithm at all to solve that, but I have a process where you can go back a couple of steps, do 1 turn, and then when you solve it from that state it will work. Now, as this cube does not work like other cubes, there is a different notation. I will put all the algorithms used, although there aren't many, in the description and in the video. Now, with square one notation, the amount that you turn a face, and as you can see it can only be the top or the bottom face, is denoted by a number. The direction is denoted by a positive or negative number. Clockwise is positive, anti-clockwise is negative. And the number is the amount of pieces that you turn. And the edges count as 1, and the corners count as 2. So, a quarter turn or a 90-degree turn would be a 3 turn, because you turn it the amount of 3 pieces. 1, 2, 3. So if you think of it in this state, to get it with the red in this position, you would turn it 1, 2, 3 pieces. Anti-clockwise, a -3 would be this. A 6 is just called a 6 because a -6 is the same. The main turning of this cube is the complete half turn of one side. This is denoted by a backslash. So usually it will be 2 numbers, a number first for the top of how many you turn, a number for the bottom, and then a backslash. And then another number for the top, a number for the bottom, and a backslash. Now this seems complicated, but seeing as there are only 2 or 3 algorithms to learn, and I'll walk you through them, this should be easy to understand by the end of this. Now, just a disclaimer on the video, this is a tutorial of how to solve it, not how to speed solve it. My method is by no means the quickest method, but I believe it to be the easiest. So if you're struggling to solve it and just want to know a way to just solve it anytime, then learn this method. A couple of problems with it is, yes, one, it may take a long time to sort out the parity, but it's easy to remember. Secondly is that getting it into its original shape may take a bit of patience. I'll demonstrate this in a minute. Okay, so let's scramble the cube. Now the 2 things that I look for in solving the cube is either when you have the top and the bottom in the same shape, which you don't at the minute, or where the edges are all paired up in even numbers. So you can have a 4, a 2 and a 2, 2 4s, or just 4 2s. In this case we have 3 sets of 2 and then 2 1s, which means it's not paired up. Now this will just involve turning and messing with the puzzle until you come into one of these cases. What I try and do is look for parts where there are two edges on one side of the split down the middle and the same on the top, and then try and match them up. It doesn't always work, but this is sort of a trial and error method. Apologies for it being a bit hit and miss. Okay, so here we go. I managed to do it so that there are a 6 here and a 2 there. So they are in even numbers. Now what you have to do is collect them all up in an 8 up here. This is done quite simply by matching them up. Line them up so that when it's either on the bottom or the top if there's a 6, and on the opposite side, so when you bring it up it will be here. If it's 2 4s, do the same, just make sure that if the 4 is on the top here, you want the 4 here. If it's all in 2s, then match them up into 4 and then do what I just said. Okay, so now we have the 8. What you're going to do, you'll have the star at the bottom and this at the top. You're going to split them in half, completely down the middle, and you'll have this shape. 4 there and 4 there, and the other side will have the same. Now what you want to do is line them up the same with the split down the middle again. So line up the middle layer like so. So 4 large, 4 small, that shows it better. And split again, and you will have this sort of bow tie shape. There we go. And this time you want to get them perpendicular to each other, so one facing up and one facing across. Line them up with the middle so you can swap them. Do the same. Now you'll now have this shape, which is quite important because this is the one before, getting it back to the square. Line them up symmetrical like so, get the middle and twist them there. Now we have the top and the bottom sorted. The shape shifting is done. We have a middle layer parity here. There are 2, and I'll explain this one now. I was going to save it till the end, but seeing it's come up, I'll do it now. For this one, you swipe, turn the top 6, or 180 degrees, swipe again, turn the top 6, and swipe again. And now it's back in the cube form. Blah, blah, blah. Right, so stage 1 is done. The next step is to match up 2 corners. Look around the cube to see if there are 2, and there are 2 here. If not, just give it a twist and see if it comes up. So here we've got our 2. Now what you want to do is add a third. So here is the orange, green and yellow, and here will be the yellow, green and red, which is here. And what you want to do is line it up so that when you bring it over it will be here. So we want it at the back right. Move the middle edge, middle layer in line so it's on the left of the middle. Okay, so now we're going to turn the top 1 and swap it in. Now we've got 3, find the other on the top. Right. So now you've got the third one in place. What you want to do is keep the 4th corner and put it at the back right top position. And now you're going to turn the top 1, swipe, do a -3, which is a 90-degree turn to there, swipe. Now you've matched these 2 up at the back. You're going to do a 3 turn, which is a clockwise one, and swipe again. Now you can leave the middle layer as it is because it's an odd numbered number of swipes. But if you want to sort out the parity again just for peace of mind, then go ahead. And you have the bottom layer done in terms of corners. Now we've been very lucky in this case and the top layer has sorted itself out. This is one of 3 cases that the top layer can be in. Okay, so here is the second case, the most likely case and the one we can work from. It is where you've got all 4 in the bottom ones in the correct position. You will have 2 that are in the right position and 2 that need swapping. To do this we'll need an algorithm and we need to use it twice. The algorithm is the only algorithm that involves shape shifting the cube, but it goes straight back into its original shape. So what you want to do is have the two matched corners on top and on the side, left or right, it doesn't matter. Now do a full turn, do a 3 on top, do another turn, do a -3 on top, do a -3 on bottom, and do a turn, and then do a 3 on the bottom and turn. Now what this will have done is kept one pair on the top, these two need swapping now, not these two, and made only one pair on the bottom. What it does is it swaps the top left back with the top left right, and the bottom left back with the bottom left right. So now, by doing the algorithm again, we can swap this with this, this with this, and we will have all 8 corners in the correct orientation and permutation. Right, so this time we need both pairs facing you. So here we go, there's one, there's two, and do the same again. So full turn, 3 on the top, -3 on top, -3 on bottom, full turn, 3 on bottom, and full turn. And there we go. All 4 corners done on top, all 4 corners done on the bottom. And now we can move on to the edges. I did mention that there was a third option that can happen, and that is where you complete the bottom 4 corners and none of them are in place. All we have to do is do that algorithm once on any of the top, and you will create a pair on top. So now we move on to the edges. There are a few circumstances, but the overall aim is to get it so that we have 2 edges of the opposite colour on each side and facing away from each other. So that one would be white and this one would be yellow, so we'd have just that and just that. But first what we're looking for is to get just 2 edges of each colour. Now to do this we need to use our algorithms, and the first one is the easy one to swap this edge here with the back bottom edge here, and this front bottom edge here with the back top edge there. And that is simply a 1 and a turn, a -1 and a -1 and a turn, and then a 1 on the bottom. And now we've got this. If you come up with any other of these cases, it will be one of the steps that I'm showing you through now, because the 3 on each side is the worst possible outcome that you can get after completing the 8 corners, sorry. The next step is to actually get 2 edges next to each other like this on both sides. Now the algorithm I'm about to show you, what it does is it swaps the top left edge with the top front edge and the bottom front edge with the bottom right edge. So these 2 swap and these 2 swap. And what we're going to do here is move this edge to here, and we're going to leave these 2 out of it, and seeing as it swaps those 2, we're going to need to move this around so that those 2 won't get swapped. These 2 will, but we're not worrying about what colour at the minute. We're just worried about getting all the same colour on each side. So here we will swap this one with this one, creating a pair there, and then we'll have our pair there. Okay, and the algorithm is nothing on top, -1 on bottom, and turn, and then a -3 on top, nothing on bottom, and turn, and then a 1 on top, and a -1 on bottom, and then a turn, and then a 2 on top, and a -1 on bottom, and a turn. As you can see, this has been left the same. These 2 have swapped, these 2 have swapped here, and those 2 have been left the same. Now what we're going to do is use that algorithm to get them so that they are opposite each other. And as it swaps these two and these two, doing the algorithm now would change nothing in terms of colour. So what we want to do is turn that one so that we have one yellow being swapped with one white and one white being swapped with one yellow. So this should get 2 yellows there and 2 whites there. Let's do it again. Nothing and -1, turn. -3 and nothing, turn. 1 and 1, turn. 2 and -1 and turn. And there you have it. 2 white on the bottom facing each other and 2 yellow on the top facing each other. So now we're going to use the top and bottom swap one more time. Quite simply get them on top of each other so that they're going to swap them. And remember, turn the top 1, turn the top -1 and the bottom -1 and turn, and then the bottom 1. And there you have it, all white on the top, all yellow on the bottom. Here is the first part where you can tell if you have parity. What you'll need to do is count the number of swaps that you need to do on top and bottom, and if they match or are within an even number of each other, so say 4 and 2, then you are fine. However, say you need to swap 3 things on top and 2 on bottom, then you will not be okay, and you need to go and do the parity process, which I'll explain in a minute. Let's count how many we have on top. Right, I can see now that it is 2 swaps that we need. I'll explain why. It's because here the blue is here and the red is there, so if we swapped these two, it would put the blue in place and have the orange and red needing to be swapped. However, if we swap here, we can put the red in place, leaving the blue and orange next to each other and only taking one more swap. So that's 2. On the bottom, it is actually the same. 1 is in place, we can put the blue into its place and then swap the red and green after. This is the most common case, is having 1 in place and 3 out of place. Now, seeing as there are 2 swaps needed on top and 2 on bottom, this is fine, which means we need to perform the algorithm twice and we will be solved. So just remember that you swap in the top left and top front. So get the 2 that you want to swap in the front and the left, which would be these 2, and do the same for the bottom. You want to put the blue in there, so like this, and okay, perform the algorithm. -1 on bottom, -3 on top. 1 and 1, 2 and -1, and 1 on bottom. And as you can see, now we have just 1 swap needed there and 1 swap needed there. Get them in the front and the top, and the front and the right for the bottom, and perform the algorithm again. So -1, turn, -3, turn, 1 and 1, turn, 2 and -1, turn, and now we complete the cube. As you can see, we have the other type of middle layer parity, which is just as easy to solve, but you can see that the top layer is completely solved, and so is the bottom. To fix this middle layer parity, you need to do a turn and then turn the middle edge 90 degrees. You can do this by just turning the middle edge, or turning the top 2 layers and then turning the top layer back, and then do another turn. It is as simple as that. And there we have the square one complete. Now, one more thing I have to show you is the parity process. Now, I'm not entirely sure how to create the parity so I can show you, but what I'll do is show you what to do. Say that I still had these 2 swapped here, which is very likely in some cases, and the bottom was done completely. What you need to do is go all the way back to the shape-shifting process and then start again. I know this seems long-winded, but you know you'll only need to do it once this way. Like I said, this isn't a speed solving method, it's just a way to definitely solve it. Plus, doing it through once and twice will just speed up you remembering this process. So what you do is you turn the cube so that you have this shape on top and bottom. Now turn the top 180 degrees and turn it to the side, so you've got one facing that way, one facing that way. Get the middle layer in the middle so you can swap them, like so. Get the bow tie shape, like that, and then get them like so, and move the middle layer to the side of one of the two pairings. It can be the side, so that you can create this shape again, the 4 big and the 4 small on top and bottom. Now, what gets rid of the parity is doing this move. Get it so that you've got 3 of the large pieces on one side and all 4 and 1 of the large pieces on the other. And this turn is what gets rid of parity. And then complete your cube just as I showed you before, starting again with the shape shifting process. Okay, if that seemed complicated, check the description for all of the algorithms and explanations. Leave a comment if you don't understand something and I'll make another video to clear it up. If you come across a case that I didn't explain, then please say. Otherwise, I hope this tutorial has helped you. Please like and subscribe, and happy cubing!